Picture this. A developer proudly launches a new mobile app. It connects perfectly to the company's servers through APIs, fast, smooth, and efficient. But somewhere in the background, a hacker sends a single crafted request, and suddenly, the app starts leaking customer data. No alarms, no warnings, just silence until the breach hits the news. That's the power and the danger of APIs. Welcome to Knowitrix, where we decode cybersecurity for the modern world. Today, we're diving deep into API security, the invisible backbone of every mobile and web app, and one of the most exploited attack surfaces in the digital era. APIs, or application programming interfaces, are the bridges that connect software systems. They allow apps to talk to servers, exchange data, and perform actions. Every time you log in, check your balance, book a flight, or stream a video, you're using APIs. Think of APIs like waiters in a restaurant. You tell the waiter what you want, the request. They take it to the kitchen, the server, and bring back your food, the response. But what if someone sends a fake order to the kitchen, pretending to be you? That's exactly what happens when APIs are insecure. APIs are powerful, but they're also doors, and if those doors aren't locked properly, attackers walk right in. APIs are everywhere: mobile apps, web apps, IoT devices, cloud services, and even AI systems. They handle sensitive data like authentication tokens, payment details, and user profiles. Because APIs are designed for connectivity, they often expose internal logic and data structures. In 2023 alone, API-related breaches accounted for over 40% of all web application attacks globally. Companies like Facebook, Twitter, and Uber have all faced API-based vulnerabilities that exposed millions of records. APIs are not just technical components, they are business assets. When they fail, the entire digital trust collapses. Let's visualize how an attacker exploits an insecure API. Reconnaissance. The attacker scans the app's network traffic, using tools like Burp Suite or Postman to identify API endpoints. Manipulation. They modify parameters, changing user IDs, injecting commands, or replaying tokens. Exploitation. If the API lacks proper validation or authentication, the attacker gains unauthorized access. Data extraction. Sensitive data is downloaded, modified, or deleted. Persistence. Attackers automate the process, exploiting the same flaw across thousands of accounts. It's not about brute force, it's about logic abuse. Section 4. Real-world case studies. Case Study 1. Facebook Developer API Breach. In 2019, a misconfigured API allowed third-party apps to access user photos without consent. The flaw wasn't in the app itself, it was in the API permissions. Millions of private photos were exposed. Case Study 2. Uber API Exploit. Hackers discovered that Uber's API didn't properly validate tokens. They used stolen credentials to access driver and rider data. The breach cost Uber millions in fines and reputation damage. Case Study 3. T-Mobile API Leak. In 2021, attackers exploited an API endpoint that revealed customer data without authentication. Names, phone numbers, and INEI details were exposed, all for a single insecure API call. These cases prove one thing: APIs are the new attack frontier. Section 5. OWASP API Security Top 10 explained simply. OWASP also maintains a dedicated list for API vulnerabilities. Let's break them down in simple, relatable terms. 1. Broken Object-Level Authorization Bowler. APIs often expose object IDs, like user IDs or order numbers. If authorization isn't checked properly, attackers can access other users' data. Analogy: imagine a hotel where every room key opens every door. That's bowler. Fix: always verify user permissions on the server side. 2. Broken authentication. Weak authentication allows attackers to impersonate users. Example, APIs that accept tokens without expiry or validation. Attackers reuse old tokens to log in. Fix, use short-lived tokens, MFA, and secure session management. Excessive data exposure. APIs sometimes return more data than necessary, like internal fields or hidden attributes. Analogy, you ask for your bank balance, but the API also sends your account number, branch code, and transaction history. Fix, filter responses, send only what's needed. 4. Lack of resources and rate limiting. Without rate limits, attackers can flood APIs with requests, causing denial of service or brute force attacks. Fix, implement throttling, quotas, and IP blocking. 5. Broken function-level authorization APIs may expose admin functions to regular users. Example, a normal user can call an endpoint meant for administrators. Fix, separate roles and enforce strict access control. 6. Mass assignment APIs that automatically bind user input to internal objects can be exploited. Analogy, you fill a form with isAdmin equals true, and suddenly you're an admin. 6. Whitelist allowed parameters. 7. Security misconfiguration. Default settings, open ports, or debug modes expose APIs. Fix, harden configurations and disable unnecessary features. 8. Injection attackers insert malicious code into API requests. SQL, NoSQL, or command injection. Fix, validate and sanitize all inputs. 9. Improper asset management. Companies lose track of old APIs still running in production. Fix, maintain an inventory of all endpoints and retire unused ones. 10. Insufficient logging and monitoring. Without proper logs, attacks go unnoticed. Fix, centralize logging and set alerts for anomalies. Section 6. Techniques and tools for API security techniques. Threat modeling. Identify potential abuse cases before development. Secure coding. Validate input, sanitize output, and handle errors safely. Penetration testing. Simulate attacks to find weaknesses. DevSecOps integration. Embed security checks in CI/CD pipelines. Tokenization. Replace sensitive data with secure tokens. Encryption. Protect data in transit and at rest. Tools Burp Suite for intercepting and analyzing requests. OWASP app for automated vulnerability scanning. Postman for API testing and validation. Insomnia for secure API debugging. Sneak Dependency Check for identifying vulnerable libraries. Wireshark for network traffic analysis. JWT-IO for verifying token integrity. API Sec 42 Crunch for automated API security audits. Section 7. Frameworks and Standards. OWASP API Security Project defines best practices and testing guides for API vulnerabilities. NIST Cybersecurity Framework provides a structured approach to identify, protect, detect, respond, and recover. ISO 27001 focuses on information security management systems. CIS benchmarks offer configuration standards for secure deployments. MASVS, Mobile Application Security Verification Standard, ensures mobile APIs meet security verification levels. Section 8. Common mistakes developers make trusting client-side validation. Attackers bypass mobile apps and directly hit APIs. Hard-coding secrets. API keys stored in source code or mobile apps are easily extracted. Ignoring token expiry. Long-lived tokens become permanent keys for attackers. Poor error handling. Detailed error messages reveal internal logic. Unsecured endpoints. APIs exposed without authentication or HTTPS. No rate limiting. Allows brute force and denial of service attacks. Weak logging. Makes post-incident investigation impossible. Section 9. Actionable steps for learners and companies. For learners, practice API testing using OWASP Juice Shop and DVWA. Learn Burp Suite and Postman deeply. Study OWASP API Top 10. Build secure REST and GraphQL APIs. Participate in bug bounty programs. Follow ethical hacking communities. For companies, implement API gateways with strong security controls. An API gateway acts like a security guard standing at the entrance of your digital building. It checks every request, validates tokens, enforces rate limits, blocks suspicious traffic, and ensures only legitimate users reach your back-end systems. Companies that rely on direct API exposure without gateways often face uncontrolled traffic, unauthenticated access, lack of centralized monitoring, difficulty enforcing consistent security policies. Modern gateways like Kong, Apigee, AWS API Gateway, and Azure API Management provide built-in features such as authentication and authorization, rate limiting, IP filtering, threat detection, request validation, logging, and analytics. This single architectural decision can reduce API attack surfaces by more than 60%. Adopt Zero Trust architecture for APIs. Zero Trust means never trust, always verify. Every request, even internal ones, must be authenticated, authorized, and validated. Companies often assume internal APIs are safe because they are inside the network, but modern attacks frequently originate from compromised internal systems. Zero Trust ensures no implicit trust, continuous verification, strict identity enforcement, and microsegmentation of services. This approach is essential for cloud-native and microservices environments. Use strong authentication and token management. APIs rely heavily on tokens, JWTs, OAuth tokens, API keys, session tokens. If these tokens are weak, long-lived, or poorly validated, attackers can reuse them indefinitely. Companies must enforce short token lifetimes, token rotation, signature verification, secure storage, revocation mechanisms, and avoiding tokens in URLs. A single stolen token can compromise thousands of accounts. Token hygiene is non-negotiable. Encrypt everything, in transit and at rest. APIs often carry sensitive data, personal information, payment details, authentication tokens, business logic, internal metadata. If this data is transmitted without encryption, attackers can intercept it using simple tools like Wireshark. Companies must enforce TLS 1.2 or 1.3, HSTS headers, strong cipher suites, encrypted databases, and encrypted backups. Encryption is not a luxury, it is a shield. Perform regular API penetration testing. API attacks are often logic-based, not brute force. This means automated scanners alone cannot detect them. Companies must conduct manual penetration testing, business logic abuse testing, authentication bypass testing, token replay testing, rate limit testing, mass assignment testing, injection testing. Tools like Burp Suite, OWASP Zap, Postman, and API-Sec help uncover hidden flaws. Penetration testing should be done before major releases, after architectural changes, after security incidents, and quarterly for high-risk APIs. Maintain an API inventory and version control. One of the biggest corporate mistakes is losing track of APIs. Old APIs remain active. Deprecated endpoints still respond. Test APIs accidentally go live. Shadow APIs exist without documentation. Attackers love these forgotten endpoints because they lack monitoring, lack authentication, use outdated logic, and expose internal data. Companies must maintain a complete API inventory, versioning policies, retirement procedures, and documentation standards. An API without documentation is a security risk. Rate limiting prevents attackers from brute forcing credentials, flooding servers, scraping data, or overloading back-end systems. Companies should enforce per-user limits, per-IP limits, per-token limits, burst control, and quotas for high-risk endpoints. Rate limiting is one of the simplest, yet most effective defenses against attacks targeting APIs, helping to ensure system reliability and prevent abuse or unauthorized access. APIs are deployed through CI/CD pipelines. If these pipelines are insecure, attackers can inject malicious code into production. Companies must secure build servers, deployment scripts, secrets management, environment variables, access controls, and code repositories. Tools like GitHub Actions, GitLab CI, Jenkins, and Azure DevOps must be hardened to protect the API deployment process from unauthorized access or injection of malicious code. Most API vulnerabilities originate from design flaws, not coding mistakes. Companies must train developers to understand the OWASP API Top 10, implement secure authentication, validate inputs and outputs, avoid exposing internal logic, use secure frameworks, and write defensive code. Security training should be continuous, not a one-time event. Regular instruction helps developers stay current with the latest secure API design patterns and defense techniques. Logging is not enough. Companies must analyze logs to detect suspicious patterns, repeated failed attempts, unusual traffic spikes, token anomalies, and unexpected endpoint access. Tools like Splunk, Elk, Azure Sentinel, and Datadog help detect attacks early, giving security teams crucial time to respond to threats targeting APIs. Security must be integrated into development, not added later. DevSecOps ensures automated security checks, continuous scanning, secure coding practices, early threat detection, and faster remediation. Companies that adopt DevSecOps reduce vulnerabilities by up to 70%, making it a powerful approach for building and maintaining secure APIs. To make this video visually engaging, here's how you can illustrate API attacks. Scene 1. Show a request leaving a mobile app, traveling through the internet, reaching the server, and returning with data. Scene 2. Visualize a hacker injecting malicious parameters into an API request. Scene 3. Show a stolen JWT token being reused to access private data, illustrating how token theft can compromise sensitive information. Scene 4. Illustrate thousands of automated requests hitting an API simultaneously, showing how rate limit bypasses can overwhelm systems. Scene 5. Show an old, forgotten endpoint being exploited, demonstrating the risks of unsecured or undocumented APIs. APIs are evolving, with microservices, serverless computing, AI-driven apps, and global cloud adoption. API security is becoming more complex. Future trends include AI-powered threat detection, automated API security testing, and API-driven supply chain attacks. Zero Trust microsegmentation, secure API gateways with machine learning, GraphQL-specific security frameworks, and API posture management tools are emerging. Companies that fail to adapt will face increasing risks. APIs are the nervous system of the digital world. They connect apps, servers, databases, cloud systems, and users. They carry our identities, our money, our conversations, our secrets. But every connection is a risk. Every endpoint is a doorway. Every token is a key. Every request is a potential attack. API security is not optional. It is the foundation of trust in the digital age. If you understand API vulnerabilities, if you master secure design, if you adopt strong authentication, if you enforce rate limits, if you monitor and test continuously, you don't just build secure apps, you protect people's digital lives. And that is powerful. This is Knowitrix, your partner in cybersecurity education. If you found this video valuable, hit the like button, subscribe, and share it with someone who needs to understand API security. Let's build a safer digital world together.